there is a good chance, if you're not very careful, of something called sampling bias. And what that is, the sample results do not accurately reflect the population. So let's say we did this survey, and in our survey, 63% of the people said they were going to vote in favor of this ordinance. The election comes along, and only 30% of people vote in favor of that ordinance. Obviously, our sample was off. So that sampling bias is the difference between the results of your sample and the real value in the population. So the whole point of taking samples, good samples, is to limit sampling bias. Notice I didn't say eliminate, because there's no way to, the only way you eliminate sampling bias is if your sample exactly reflects the population, and that's never going to happen. But let's say that this ordinance A that we're talking about, has something to do with funding for the local schools. Well, if I show up at a high school football game and I survey people at the football game, a good chance that those people at that football game have a connection to the school. A good chance that they probably have a good feeling about the school. So it wouldn't surprise me that a high portion of that group are in favor of an ordinance that favors the school. Whereas if I go, I don't know, if I go somewhere that has a group of people that don't have any kids in the school and have no connection with the school, there's a good chance that they don't care about the school, and they're not, a high portion of them might not be in favor of that item for the school. So you have to be careful that you're not taking your sample in such a way that the way you've chosen your sample will affect the results of the survey, of the data. So there's two things that we do in our effort to take good samples. One, the sample size. If I walk out on the streets and I ask the next two people I see what do they think, one says that they're in favor, one says they're against, I cannot conclude that 50% of the people are in favor of that ordinance. Way too small of a sample. In this class, we're not going to get into a discussion of what is an adequate sample size, because that is a very, very deep discussion. And one of the problems with statistics is not an exact science. Statistics has different schools of thought. And there are many, many different theories out there, many, many different rules that have been proposed, depending on what textbook you're looking at or what statistical expert you're talking to, as to what is the best way to determine the proper sample size. Now, one of them that's commonly accepted is that the sample size be greater than or equal to 30. Now, the abbreviation for sample size is the letter N. So say that N is greater than or equal to 30 at a bare minimum. Now, there are times where you can't get more than 30, and we have special exceptions and special cases for that. We're not going to, like I said, we're not going to get too deep into that conversation. Obviously, if we're dealing with a presidential election, surveying 30 people is not going to be adequate. That's not even getting one person from each state. So we're not going to get into those rules. The second is randomly chosen. You know, I used the example of going to the high school football game and just surveying people at the high school football game. Well, you might say that you walk past somebody and you flip a coin, and if it's heads, you survey them. If it's tails, you don't. That's randomly choosing, right? No. That's using randomness, but it's not randomly choosing. Randomly chosen, a random sample, is defined statistically to be every member of the population has equal chance of being in the sample. So for the example we use, people that aren't at that football game have no chance of being in the sample. So that is not a random sample. So now we're going to look at some processes for randomly choosing. The best process, the best type of sample is something called a simple random sample. The analogy for a simple random sample, to go back to the pre-technology, is basically putting names in the hat. This could be literally putting the names of everybody that is a registered voter or everybody who will vote in the next election in a hat. Again, there's a problem of defining who is actually in that population. But putting everybody in the population in a hat, whether it's their name or assigning an identification number to them, mixing them all up and then drawing out however many you're going to have in your sample. Now, it's very important that before you start, that you determine the sample size before you select. In all of these, you need to determine what size your sample is going to be before you start selecting a sample. That stops you from just starting to select and getting to a point and say, oh, yeah, that's enough. By predetermining your sample size, it forces you to stay more systematic in how you choose that sample. It sounds like it won't, but there's actually been studies done that show a huge increase in sampling bias if you don't predetermine that. So like I said, names in a hat. Simple random has an added qualification. Not only is it random, not only does every item or element in the population have equal chance of being in it, but every group, every sample of size n. Remember, n is the size of the sample, the number of items in your sample, has an equal chance of being chosen. Now you might be looking at thinking, well, that seems obvious. If every person has an equal chance, well, every group of that size has a possible chance. But we're going to look at some processes where it's not necessarily so. There are samples, some textbooks refer to them as samples of convenience, but there's something called a convenience sample that's much different. So we're going to look at samples that are random, but not simple random. One of them we're going to look at is something called a cluster sample. A cluster sample is actually very, very common if you're going to do door-to-door sampling. Now, door-to-door doesn't necessarily mean you're knocking on somebody's door and asking a survey. In the telecommunications industry, happens a lot where they actually go to houses and test the signal on the outside of the house. Well, if they throw the names of everybody in the city into a hat and draw them out, they're going to be skipping around all over the city testing these signals. So what a cluster sample does is it divides the population into groups. Then randomly selects several groups. So again, back to that telecommunications example. If they have to send out a technician to go to the houses that are selected and go to the box on the outside of the house, pull the cover off, and test the signal level, it would make sense to divide the city up into square blocks, into city blocks. And rather than randomly selecting single houses, they randomly select whole city blocks. So they're going to test this block, and this block, and several others. So when they send a technician out, well, that technician is crawling through the backyards. They can test this house, this house, this house, all the houses that are on that block, and they can test them. They can park their vehicle and go walk down the block and get it done. Then they can go to the next block that's been chosen. Otherwise, it would be really a logistical hazard to have one here, one here, one here, one here, jumping all over the place, in and out of the vehicle, going. It's just a huge expense and a huge hassle. So it makes sense in a lot of cases to choose groups and then get information from that whole group at each time. Now again, that's random because every block in the city has an equal chance of being chosen, but it's not simple random because it's not possible to choose a sample that has one person from each block. Or it's not possible to choose a sample that has this person on that block, but not the person next door to him. If you're on that block, you're going to be, your whole block's chosen or not chosen. So it is a random sample, but not a simple random sample. It is still valid. The next one is what we're going to call a stratified sample. In a stratified sample, you still divide the population into groups. But this time, rather than selecting whole groups, you randomly select a specific number from each group. For example, if I want to do an employee satisfaction survey for a manufacturer, I am going to divide my facility into departments. And I'm going to randomly select a certain number for people from each department. Now, for this to be valid, a bigger department, you have to select more people from it. If Department A is twice as big as Department B, you have to select twice as many from that department as the smaller one. But what that means is still every person in that facility has equal chance of being chosen. But it's not possible to choose a sample that selects everybody from one department. The reason for doing this is you want to get a good cross-section. You want to make sure you're gathering information from every group. If I wanted to do a survey on students at WITC, I would most likely divide it up between business students, trade and technical students, law enforcement students, health and human services, from different groups, and then randomly select the appropriate number of people from each of those groups so that I can get information about the students. Again, that's random, but it's not simple random. There's systematic samples. In a systematic sample, you randomly choose a starting point. And then the system goes from there. A good example of this would be in manufacturing. Let's say in a manufacturing setting, you need to test, we're talking about, destructive testing on those parts, strength testing those parts. let's say you decide you need to test 1 out of every 200 parts produced. Well, what you're going to do then is every morning, you're going to randomly choose a number from 1 to 200. Let's say that on a given morning, you choose 57. So what's going to happen is you're going to choose the 57th part that comes off the line. You're going to take that part and you're going to go test it. Then the 257th part that comes off the line, you're going to go test it. The 457th part that comes off the line, you're going to go test it. You need to test 1 in every 200, so you're going to choose that first one, and then after that, every 200th part gets tested. Does that make sense? So it's still random. Every part has a 1 in 200 chance of being selected, but it's not simple random because it's not possible to get 2 parts within that first 200. The final type of survey the type of sample that we're going to discuss is called a convenience sample. I'm bringing this sample up only as a warning. A convenience sample is you take what's easy to get. So it might be I walk out the door and I survey, if I need to get 200 people, I walk out my door and I survey the first 200 people I see. Well, that's convenient. Or I survey 200 of my friends. Again, that's convenient. A convenient sample is just taking information the easiest way you can get it, or a way that's easy for you to get it, and that is usually not good, well, almost never good. Now, there's another thing I'm going to actually throw out here that's a problem with almost every type of sample that involves people. A self-selected sample isn't necessarily a type of choosing the sample, but it's a problem you have when you're going to gather information from people. It's because people might refuse to respond. If I want to ask, if I want to figure out what is the average income of students at WITC while they're going to school, well, some students might be very touchy about giving out that information. You can't force them to respond. The biggest issue with self-selected samples is when you do mailing surveys. If you mail out a survey, generally you get between a 20 and 30% response rate. So if you need 200 responses, you're going to send out at least 700 to 800 surveys to get those 200 responses. Generally, think about it. If you get a survey in the mail and it's about a topic that you really don't care about, or a topic that you're really against, yeah, exactly, it's going in the garbage. If it's something you really care about, you're going to take the time to respond and send it back in. So the self-selected samples generally are going to be skewed in favor of whatever topic it is. When I was in college, I actually did a study, a project where we sent out political surveys, and we got permission from the Wisconsin Democratic and Wisconsin Republican parties. They actually gave us 500 envelopes from each party. So we sent out identical surveys. All they had was a little symbol at the bottom of the page so I could identify what envelope it was sent out in. And it was sent out, 500 of them were sent out in envelopes that said from Wisconsin Republican Party. 500 were sent out in envelopes that said from your Wisconsin Democratic Party. Well, guess what? First of all, out of each of 500, we got about 100 to 120 back. The ones that went out in the envelope for Wisconsin Republican Party came back with much more conservative results to the political questions. Because if you're a liberal person, if you're a Democrat, if you're associated with the Democratic Party and you get a letter from the Wisconsin Republican Party, it's not getting opened. Most of the time it's going in the garbage. And the same in the other direction. So that is a huge problem. Even if you walk up to someone or knock on their door, there's always that option of refusing to participate.